All right, guys, so what we're starting today is Chapter 5, Precalculus Chapter 5.1, Analytic Trigonometry. And so what we're going to be starting out with first is kind of just utilizing some of the fundamental identities. And we've looked at some of these before, and we're going to look at some more here. So rewriting fundamental identities, write and evaluate functions, simplify and rewrite trigonometric expressions. Reduction. So evaluate, we want to evaluate, simplify, develop, and solve. Now this here is a pretty decent good size chart because we have sine, cosine, and tangent with our reciprocal functions, secant, cosecant, and cotangent. We also have the quotient identity that tangent is equal to sine over cosine, cotangent is equal to cosine over sine. We have our Pythagorean identities. Sine squared plus cosine squared is equal to 1. 1 plus tangent squared is equal to secant squared. And 1 plus cotangent squared is equal to cosecant squared. And we've seen all of these. So those first three we have seen. We've also seen our cofunction identities. Our pi over 2 are 90. So sine of pi over 2 minus u is equal to cosine of u, or kind of when we talked about sine of 90 minus theta is equal to cosine of theta. Same is true for cosine, tangent, cotangent, secant, and cosecant. We have these here, and we've seen these. And then we have even and odd. And we've talked a little bit about even and odd also, that sine of the negative angle is equal to negative sine of that angle. Cosine, since it's even, cosine of a negative angle is equal to cosine of that angle. They work out. Tangent, cotangent, secant, and cosecant, they all have these properties, and they're going to be helpful, especially moving forward. So these here, I will have a printout when I get back and I'm in class and I see you guys next. I will have a printout of this here for you, of all of these properties here and all of our identities that you can use and reference. So you'll have a reference sheet for these here. But until then, these are in the book and you can reference back to them, and I would be referencing back to them. Now, just because they're set up in this way doesn't mean we have to stick with this form. So most specifically, let me get a highlighter out. These three here, the Pythagorean identities, these three are more specifically what I'm talking about here. These here we will utilize throughout the course of this chapter, and we've already utilized them before, but we don't have to leave them in this form. So say sine. Sine squared plus cosine squared equals 1. Well, we don't have to leave it in that form. So like this here, sine of u is equal to plus or minus the square root of 1 minus cosine squared of u. And really what they did is they took the original equation, this here, sine squared plus cosine squared equals 1. And I know it's a little bit fuzzy, but they took this equation and we took this equation and solved. And the way they did that is, well, first they subtracted cosine, which gives us our 1 minus cosine squared. Okay, I'm going to go on and just show you guys this on out and work this kind of through. So what they did is they took this original equation, I kind of typed it out already. So sine squared plus cosine squared equals 1. And the first thing we did was we subtracted cosine from both sides. Cosine squared from both sides. And when we subtract it from both sides, we get sine squared by itself is equal to 1 minus cosine squared on the other side. Now at this point here, well, sine squared, we still have sine squared. So to get rid of sine squared, what they're going to do is we're going to take the square root of both sides. And we square root a square, it will simplify. And over here, we're going to get the square root. Oh, here. We'll get the square root. Now again, when we square root both sides, we have to include the plus or minus, which they did here. So sine of our angle is equal to plus or minus the square root of 1 minus cosine squared of that angle. Now, the sign plus or minus is going to depend on u, kind of where the sign depends on the choice of u. Now that seems a little weird. Why is it all dependent on u? Well, what they're really talking about is our angle in the quadrants. So I kind of put this up here for us. Now in quadrant 1, sine is positive. In quadrant 2, sine is positive. Quadrant 3 and 4, sine is negative. So if the angle we're looking at, so say sine of 120 degrees is in the second quadrant. So the value of sine, the values that are going to come out of sine at 120 degrees are going to be positive. Now, if we're looking at quadrant 3 and 4, so sine of 220 or sine of 320, the value coming out would be negative. So that depends on our plus and minus. So if we're taking this here using, let me get my highlighter again, this here, this equation here. And the value, the angle that we're looking at, the angle U is in one quadrant, 1 or 2, is between 0 and pi, or 0 and 180, then, or kind of multiples of in that range. If they lie in quadrants 1 and 2, either 0 to pi or 0 to 180, or kind of any coterminal angles that lie in there, the value of sine would be positive. So we would take the positive case. But if it lies between pi and 3, or pi and 2 pi, or 180 and 360, or any coterminal angles that lie in the third and fourth quadrant, then it would be negative. So it depends on where the angle lies. Which quadrant is it in will determine the sine. The same goes for cosine and tangent or cotangent. We could have any one of these four. And if you're wondering for cotangent or cosine, it will be the exact same equation, except we're switching sine and cosine, or secant and tangent, or cotangent and tangent. So this here would be cotangent of u plus or minus the square root of cosecant squared u minus 1. And we can get them there, and we can do different ones. We're just solving for one of the terms. Now, if you're wondering, well, how do I know which one I'm going to use? Well, how do I know if I need cosine of u is equal to, or sine of u is equal to this one here? Well, it's all dependent on what we need. If we're wanting to try to simplify out cosine, then I'm going to try to use sine. If I'm trying to simplify sine, I'm going to use cosine. I'm going to use whichever one I need in order to simplify, or what my goal is. It's all dependent on what my goal is that I'm trying to do. So kind of let's look at this here, using the fundamental identities. Now, one common application of trigonometric identities is to use given values of trigonometric functions to evaluate others. And we've done this a little bit, like this here. Use the value of secant u is equal to -3/2, and tangent of u is greater than 0 to find the values of all 6 trigonometric functions. Well, one thing we know for certain is that, well, since secant is the same as what? 1 over cosine. Secant's the same as 1 over cosine. So really, I already know what cosine is. So cosine of u is equal to the flip. Is equal to the flip of secant. So since secant of u was equal to -3/2, cosine of u, which is 1 over secant, is equal to -2/3. We just flipped it, because it is the reciprocal function. So that gives us cosine. Well, we're 1/3 of the way done. We have 2 out of the 6. Now we need to find the rest. Now I jump back here because I want to look at this chart here. Well, so we know secant. We found secant and cosine because we use this here. We found these two. Now looking at the rest of these, well, since I have secant and cosine, well, cotangent, I already have half of it because I have cosine. Tangent, I already have half of it because I have cosine. Now, if I'm able to find sine, well, I can use those two values to find tangent, and I can also get cotangent. And once I get sine, well, I can get cosecant, because cosecant is just 1 over sine. So I can just flip it. So really, to get the rest of these here, I really need to get sine, because once I get the value of sine, I will get cosecant, tangent, and cotangent from that, because if I have sine and cosine, I can get the rest of them. Well, our only properties that deal with sine and cosine together is our Pythagorean identities, this one right here. That sine squared of u plus cosine squared of u is equal to 1. Now we can use this here, or we could use this one here. Sine of u is equal to plus or minus 1, the square root of 1 minus cosine squared of u. Either way, we can use it to get our answer, just depending on which one we want to do. So I'm going to use the fact that sine squared of u plus cosine squared of u is equal to 1. So I'm going to just use the basic fundamental theorem, this one here, the Pythagorean theorem. Now what we know is that cosine of u is equal to negative 2/3. So I'm going to plug that in for cosine. And what that'll give us is plus negative 2/3 squared, because again, it's cosine squared. Well, if cosine is negative 2/3, cosine squared would be negative 2/3 squared. Now at this point we can simplify, so we get sine squared of u plus, well, negative squared is going to be positive. 2 squared would give me 4, and 3 squared would give me 9, is equal to 1. Now at this point here we can subtract the 4/9 from both sides. And if I subtract 4/9 from both sides, I would get 5/9. Because 1 minus 4/9 would be 5/9. And at this point here we can square root both sides. And when we square root both sides, we get sine of u is equal to plus or minus, because whenever we square root both sides, we have to have the plus or minus, square root of 5 over 3. Because we can't take the square root of 5, but I can take the square root of 9, which would be 3. And we get this here. Now we need to deal with the plus or minus. And that's coming back up here, this piece here. It told me secant of u is negative 3/2, and tangent of u is greater than 0. So to find the rest, we already use these here. Now, secant of u, negative 3/2, told me cosine is negative 2/3. So I'm going to draw a little quadrant over here. Now, looking at this here, the fact that cosine is negative, well, there's two spots. Because if cosine is negative, we're either in the second or third quadrant, because those are the only two places where cosine is negative. Now the other piece of information they gave us is that tangent is positive. Well, the only two places where tangent is positive is in the third and first. Now where's the only spot where both of those line up? It's down here in the third quadrant, and that's really what this is telling us. I skipped over this. This should have been the first thing I talked about, is this here, where sine, cosine, and tangent, where all they're going to lay, but I didn't. So that's where we're coming back to this here, with this plus or minus. So since this here, because cosine and secant are negative, well, they're in the third quadrant or second quadrant. Tangent is only positive in the first and third. So since they both line up in the third quadrant, that means every angle is going to be in the third quadrant. So for us here, well, in the third quadrant, sine is negative. So sine is going to be negative 5/3. Okay. Okay, now that we have these two here, we have sine and cosine, we can find the rest. Now, what they were talking, so solution, you use the reciprocal, and this is what we did, and we found out that cosine is negative 2/3. And now they used this form of the Pythagorean identity and plugged it in, 1 minus, parentheses, negative 2/3 squared. And got this here simplified to 5/9. They didn't square root, but we needed to, and they will. Now, because secant is less than 0 and tangent's greater than 0, it follows that u is in the third quadrant, which we talked about and went through. Moreover, because sine of u is negative, when u is in the third quadrant, we choose the negative root and obtain this here, which we found. And we had sine and cosine. We also had that secant, which they gave us to start with, was 1 over cosine sorry, cosecant Okay, now that I'm looking at this here, these slides seem to have a little bit of a mistake because we first start out with secant, which they're going to say is negative 3/5. Well, we know that's not right because, well, secant of u is equal to negative 3/2. Is equal to negative 3/2. Okay, well, that's not quite right because, well, because we did find out cosine's negative 2/3. Well, secant's 1 over it, so it really should be negative 3/2. And they've got them flipped because if we look at cosecant, well, it's got it as this here. So they have these flipped a little bit because 1 over sine, well, sine is negative square root of 5 over 3, which would give us this here negative 3/5. So they've got these flipped. Really, this one's this here, this one is this here. So they had those flipped. Now tangent is going to be sine over cosine. Sine over cosine. So negative 5 over the negative square root of 5 over 3 over negative 2/3. Now if we type this into the calculator and simplify, we'll get square root of 5 over 2. And the same thing is true with cosine, or really we can take 1 over tangent, really just flip tangent. So we know tangent's the square root of 5 over 2. If we flip it, we get 2 over the square root of 5. And we could plug that into a calculator and simplify and get 2 square root of 5 over 5. And that's it. So we're really using these properties of sine, cosine, tangent, secant, cosecant, and cotangent to find the values, as well as using the fact of determining which of the 4 quadrants it lies. And that's it. Now there's going to be some more problems dealing with this here and on the assignment, but we've done this, and I feel that y'all should be pretty comfortable with this here. If you have any issues, please let me know. Now the last thing we're going to talk about is simplifying trigonometric expressions. So this one here, we have sine of x times cosine squared of x minus sine of x. And what we want to do is try to simplify this as simply as possible. And most of these here, we're going to try to write it as a term. We're going to see if we can write it as a term, a single term. Now when we look at this here, well, I notice that there is something in common with both of these terms. Because if I look at this term here and this term here, well, they both have a commonality of sine. So what I'm going to do is I'm going to factor it out. I'm going to factor it out of both terms. So I have sine of x times, well, if I factor sine of x out of cosine, or sine of x times cosine squared of x, what I'm left with is cosine. I'm just left with cosine squared of x. Now when I factor sine out of sine, I'm just left with 1. And it's going to be negative because it's minus sine, so it would be minus 1. And we're left with this here. Now, we're not going to do anything to the sine of x, but we're going to do something to the cosine squared of x minus 1. Now, I'm going to go back a few pages. Back to these here. I'm going back to this. And it's really coming back to this Pythagorean identity. Sine squared of u plus cosine squared of u equals 1. Well, one thing we do know is that when we solve this, that sine squared is equal to 1 minus cosine squared of u. And that's what we're going to use. And just to kind of get an idea, it's this here, this Pythagorean identity. Sine squared of u is equal to 1 minus cosine squared of u. And we're going to utilize that here. Now, if you notice, it does look a little bit different. So I went on and grabbed it and pulled it over here. Now, if you notice, this part here, this here, and this here do look different. Because here at cosine squared is positive. Here it is negative. So that there is not a terribly hard fix to make, because what I can do is to change it from positive cosine to negative is that we can factor out a negative 1. We can factor negative 1 out of both. And what that does is it turns cosine from positive to negative, and it turns the negative 1 from negative to positive. So it changes the signs, which doesn't seem like too big of a deal. But what we can do, when I change that sign, I can also rewrite it. And I'm going to move the 1 in front. Because when I factor out that negative 1, well, it's almost the same as flipping those, and kind of we can rewrite it. Now we have it the same. Because once I factored out that negative 1, I changed it from cosine squared of x minus 1 to 1 minus cosine squared of x, which is the same as this here. Which means that I can replace the 1 minus cosine squared of x with sine squared of x. And it's going to be negative because we're going to multiply it by that negative 1. So what I did was I replaced 1 minus cosine squared of x with sine squared of x. Because sine squared is equal to 1 minus cosine, so I can replace it. And we have it negative because of the negative 1 out front. And we're almost done. Because now sine times sine squared is going to be negative sine to the third. Because squared 1 times sine times sine squared will be sine cubed of x. And that's it. So when we're simplifying, we're wanting to manipulate the equations in such a way that we get them down simpler, as simplified as we can get. And really keeping everything in the numerator and not having any fractions is going to be what they're going to consider simplest. And that's it here. Now we're going to do one more of these here, and I can do more of these when I get back. But this is what you're trying to do. You're just trying to manipulate the equation. So they looked at this here. Now for them, they factored out negative sine of x, multiplied them together, and got it here. And that's it. So this here is the last one we're going to look at. All right, so what we're looking at is this here. We want to rewrite 1 over 1 plus sine of x so that it's not in a fractional form. Now, most likely, as you've noticed, we're probably going to have the Pythagorean identity show up, and it will. And that's the main way. And the reason I know that's kind of, well, because I've already worked through this, but also because when we're talking about sine and cosine and simplifying them, the only main way that we can have that when the variable or kind of angle is by itself is using the Pythagorean identity. It's the only real way we can simplify sine and cosine and have it in a simpler form. So what we're going to do first is we're going to try to simplify this fraction if we can. And what I'm going to do is I'm going to multiply the numerator and denominator by the reciprocal of 1 plus sine of x. Now, part of the reason for this is because of the fact that 1 plus sine of x times 1 minus sine of x is going to work out in a particular way, in a very interesting way. Because when we simplify this, on top, on the numerator, in the numerator, we're just going to have 1 minus sine of x. Because that's all that's going to be left over in the numerator. Now in the denominator, we're going to have our 1. Now because it's a difference of signs, the middle term would cancel out because we'd have 1 times 1 is 1. Then we'd have minus sine of x plus sine of x, which would cancel. And then we would just be left with 1 minus sine squared of x. Sine squared of x. And that's kind of what we want. We want this here. We want this setup. And the reason we want this setup is because, again, and I kind of moved to the next page, part of the solution, is from the Pythagorean identity, that cosine squared of x is equal to 1 minus sine squared of x. And if we had factored it out and kind of went along this line of thinking, it's equal to 1 times, or 1 minus sine of x times 1 plus sine of x. And that's what we did. We multiplied the numerator and denominator by 1 minus sine of x to produce this 1 minus sine squared of x on bottom. And once we produce this, well, hey, it is cosine squared of x. This is cosine squared of x. So what we can do is we can replace our 1 minus sine squared of x in the denominator with that there. Okay, now I know that you already saw all those steps probably, but I want to walk us through, so I went on and erased them, and we'll put them back. Now we replaced it with the Pythagorean identity and got 1 minus sine of x over cosine squared of x. Now again, our main goal is to rewrite this without fractions, but as you're looking at this here, well, we obviously still have a fraction, 1 minus sine of x over cosine squared of x. We really didn't simplify anything. So what we need to do is we need to do some more steps. One of the nice things is that if there's an addition or subtraction in the numerator, not the denominator, in the top of the fraction, we can rewrite it. We can break it apart. And that's what we're going to do first, is we're going to split this apart. Because 1 over cosine squared of x minus sine over cosine squared of x is the same as 1 minus sine of x over cosine squared of x. We can split it up if there's addition or subtraction in the numerator. We cannot do the same thing if it's in the denominator. So that's part of the reason why we got cosine squared of x by itself in the denominator. Now, they're going to talk about product of fractions. And really what that means is that, well, we're going to just rewrite the second part like this here. It's not a big change. It's not a big difference. But what we want to use is really our reciprocal identities. 1 over cosine is the same as what? As our secant. So 1 over cosine squared is the same as 1 over, or just secant squared. 1 over cosine squared is the same as secant squared. Sine over cosine, well, that's tangent of x. And 1 over cosine is the same as secant of x. And that's it. Now, we could factor out the secant and do this here, but it's not really making it any simpler. But this is what we do here. And I know that might be a little bit confusing, but really all we're doing with all these steps here is just manipulating the equation to write it in a simpler way or without a fraction. And that's it. That's all we'd have to do for this here. Now this here is your assignment. I unfortunately don't have the textbook with me to be able to look over these problems and see what they are. So I want you to go on and get them started and give them a try. I'm going to get in contact with Mr. Matney if he is doing hopefully he will be subbing for all my classes and being the sub for them. And hopefully I'll be able to have a chance to look at these here and get a picture of these and see them. So go on and give them a try and work on them, and I will work and be flexible with this here. So if you get stuck, please let me know. Try your best on these here, and we'll go from there. And that is it.